Okay, this is a little tutorial for the first worksheet on how to write formulas for binary ionic compounds. And one of the things we learned is that, so let me just do the first couple on the worksheet. So, okay, come on, I need to have a pen. Oh, there it is, it's coming. The first one on worksheet number 1 is lithium oxide, and we are learning the International Union of Pure and Applied Chemistry naming rules. So UPAC stands for International Union of Pure and Applied Naming Rules, and basically the positive ion is listed first. And so if you go to the ion sheet that all the kids were given, you'll notice that the positive ions are over on this side in alphabetical order by name. And then when you go back, the negative ions are listed second. And the most important thing, so positive ion is first, negative ion is second, and that the overall charge on the molecule has to be 0. So charge must add to 0. And so what happens is, I'll just run through some on the worksheet. Lithium oxide, the first thing you do is you go to your ion sheet, and I can't write on here, but if you look, lithium is right here. I'm kind of going to show you with moving the mouse. But lithium has a symbol of capital L, little I, and a charge of +1. This ion sheet will be provided to you on test day. So lithium is Li +1. And then you look up oxide because the positive ion is listed first. So lithium is the positive ion. And then you go back and you can see oxide up here is O -2. It actually comes from oxygen. In a minute, I'll show you how those names up there came. And so you write down the ion symbol and then the ion charge. Okay, now after you do that, positive ion listed first, negative ion listed second, then you say to yourself, do +1 and -2 add to 0, and they don't. +1 plus -2 with -1. When that happens and they don't add to 0, you have to find the least common multiple, which is very similar to what you do when you're adding fractions, called the least common denominator. But what is the smallest whole number that 1 and 2 will go into evenly without a remainder? It's 2. So then you say to yourself, what do you have to multiply 1 by to get 2? And that is actually 2, and we put this as a subscript. And then what do you have to multiply 2 by to get 2? And that's 1. And in chemistry, we don't actually write down the ones. We write Li2O. Looks a lot like the formula for water, which is H2O. And really what happens here, this formula tells us that we have 2 lithium ions, and each of them has a +1 charge. And then 1 oxide ion, which has a -2 charge, and +2, -2, and now it adds to 0. So all you need to know is when you do this worksheet, you look up the positive ion symbol in charge, you look up the negative ion symbol in charge, and then you say to yourself, do they add to 0? Sorry, didn't mean to do that. New sheet. On the set of problems you turned in today, the next one was, sorry, get the eraser. I screwed up. Get the pen. The next one on the worksheet was potassium bromide, and this is what we need to keep in mind. The positive ion is listed first, so you look it up. It's K +1. The negative ion is listed second. It's Br -1. First question, do +1 and -1 add to 0? The answer is yes. When that happens, we just slam them together. We only have to do the least common multiple if they don't add to 0. Okay, now jumping down to like 10, and this is worksheet number 1. I'm going to do about 5 of these for you. Um, Number 10 is zinc chloride. Sorry, I didn't write that very good. You should see the little, when you go to your sheet, which is right here, notice zinc's down here. Zinc has a symbol of Zn and a charge of +2, and chloride has a symbol of Cl and a charge of -1. And so zinc has a, sorry, zinc has a symbol of +2 and a chlorine is C, big C, little l, -1. Do +2 and -1 add to 0? No. So we have to find the least common multiple, which is the smallest number that 1 and 2 will divide into evenly, which is 2. So what do you have to multiply 2 by to get 2? 1, but we don't write down the ones in chemistry. What do you have to multiply 1 by to get 2? 2, and so the formula for zinc chloride is capital Z little n, capital C little L2. And basically what's happening here is you have a zinc ion with a +2 charge, and you have a chloride ion with a -1 charge, and you need to have 2 of them before +2 and then +(-1), +(-1). The most important thing is that it adds to 0. Um, let's do a new, oh, so I didn't really want to do that, but that's okay. Um, okay, back here, let's go to a new slide. Let's jump up to, I don't know, my favorite, which is, I have no idea what I push sometimes. I apologize. On 20 is lead 4 phosphide. And notice this might be my first one where I have a Roman numeral, and that's because if we go to our ion sheet, sometimes lead has a +2 charge, and so we call it lead 2 because the charge is +2. And sometimes lead has a +4 charge, and when that happens, we call it lead 4 because it has a +4 charge. And so what happens is lead is Pb, comes from the Latin word plumbum, +4, and then phosphide comes from phosphorus, and that has a -3 charge. And let me just show you where that comes from. I'm going to talk about this. Phosphide is right here. It's -3. And then again, the question is, after you look up the positive ion, write down its symbol and charge, and the negative ion, write down its symbol and charge. You ask yourself the question, do +4 and -3 add to 0? They don't, so you have to find the least common multiple, the smallest number that 4 and 3 will divide into evenly, and that happens to be 12. What do you have to multiply 4 by to get 12? That would be 3. And what do you have to multiply 3 by to get 12? And that would be 4. And so what happens is you have 3 leads, and each of them has a +4 charge, and you have 4 phosphides, and each of them has a -3 charge. And if you see that, you'll get +2, +12, plus -12 equals 0. Yeah, the last thing I want to tell you is, because this is important for the remainder of the course, where these weird names come from. They're slightly weird up here. And so and I'm doing these anions, so cations are positively charged and anions are negatively charged. And what happened was when a positive ion bonds with a negative ion, the negative ion has a name change to indicate that it is now bonded. Just like when I got married, my maiden name was Wilkinson, my married name is High. And there's a really cool way they did this. So Br as an atom is called bromine, and when it's bonded, we chop it off in front of the second vowel and we add IDE. So when Br is alone, we call it bromide. Bromine, when it's in a compound, we call it bromide. When chlorine is alone, we call it Cl. When it's in a compound, we chop it off in front of the second vowel and add the ending IDE. When fluorine is alone, we call it fluorine. F, when it's in a compound, we chop it off in front of the second vowel and its name becomes fluoride. Um, when when iodine, now this one's kind of crazy. I say second vowel, but when two vowels are together, we go by like the vowel sound. Iodine is I. When it's in a compound, it becomes iodide. And now things start getting interesting. I'm going to go back to this. So I did bromide, chloride, fluoride, iodide. Nitride is interesting. Nitride actually comes from nitrogen, and if nitrogen alone is N, if you chop it off in front of the second vowel, it becomes nitride. So nitride actually comes from nitrogen. Oxygen is O, and A-E-I-O-U, sometimes Y is a vowel too. So you chop it off in front of the second vowel, which in this case is the Y. It becomes oxide. And new slide, phosphorus, which is P. But when it bonds, we chop it off in front of the second vowel and it becomes phosphide. Sulfur, S-U-L-F-U-R, you chop it off in front of the second vowel and it becomes sulfide. And that's where those names come from for the anions. So I hope this helps for worksheet 1. I'm going to push stop and save it and send it to you.